So the first thing, we need a game plan. A game plan. 1, set unequal to 0. Or set equal to 0. That's ugly. 2, find the zeros. 3, test intervals. 4, choose the appropriate set. How do I spell appropriate? A-P-P? R-O-P? Appropri. I? R-I-A-T-E? R-I-A-T-E? Appropriate intervals. All right. Boom. So the first thing we needed to do is set it equal to 0. And that's what we're going to do over here. So I'm going to subtract off. I need my x's on one side. I got them on both sides. Which side? Don't care. Yeah, left-siders. I subtracted off a 10x. And I subtracted off a 10. And then, let's just say that's equal to 0. I don't remember what color I had. That looks about right. Funky pink. Nope, that wasn't it. Oh well, I got that there now. Now what are you going to do? How are you going to solve that, huh? Factor by grouping. You take them 2 at a time. That gotta sound familiar. What do I pull out of that first group? X cubed. Then what was left over on the inside?
X squared.
And x squared minus 10. Very nice. Whoops. It should have been this terrible green. Terrible. Yeah.
Or grass green. Don't have to be negative.
What am I pulling out of this group? Yeah, pull a 1 if you have to. Plus a 1. And then you have the x. I should put that in the right color too. Oh, messed it all up. Funky, funky. That's still going to be equal to 0, but you have a common factor, and once you have that common factor, you can pull it out. You can pull it out front or out back. It is your choice. We're finding the zeros. So then, that's an x squared minus 10 times x to the 3rd plus 1. Sneaky! Oh my! That's just good times right there. So let's take that. Right on. Over here. That was x to the 3rd plus 1 and x squared minus 10?
Yeah.
And that was equal to 0. Okay. So then you set each one of those equal to 0. But this one in the middle, factors, what am I talking about? I'm talking about this. It follows the rule of SOAP. If you had a to the 3rd plus b to the 3rd, that's a plus b times a squared, same opposite, minus ab plus b squared. That's dot dot dot, or 4 dot. Yeah, it's 4 dot, 4 dot. There's 4 dot and 5 spot. So yeah, that first green one is going to factor, and it factors into crappy green, x plus 1 times x squared minus x plus 1. And then this guy is still x squared minus 10 is equal to 0. So now we set each one of those factors equal to 0. Woo! So we say x plus 1 is equal to 0, or x squared minus x plus 1 is equal to 0, or x squared minus 10 is equal to 0. Why? Because of this stuff over here. We're to that spot where we factored it and we set each factor equal to 0 so that we could find our zeros. Why did we want to find our zeros? Because we have this. First we want to set it equal to 0. Then we want to find the zeros. Then we want to test the intervals and choose the appropriate intervals. All right, where are we? We're at finding the zeros. What? So yeah, this one says x is equal to minus 1. How do you do the center one? This guy. Quadratic formula. X is equal to minus b plus and minus square root. We're only looking for the real zeros, though, because those are the only ones that are going to try the sign. We can find the number and the nature of the zeros by looking at the discriminant ahead of time. So b squared minus 4ac, that's going to be 1. What was that? X squared minus x plus 1? B squared minus 4ac, all discriminant on it. So this is 1 minus 4 times 1 times 1, which gets you a minus 3 in total. So what does that say? How many solutions are there going to be? 2. Are they going to be real or imaginary? 2 imaginary solutions, because the discriminant came out negative. Why did I do that? I mean, we didn't have to worry about this, because they weren't real solutions. You could have found them, but I spent just as much time not finding them. So this is minus the square root of 10 and plus the square root of 10. Where'd those come from? Those came from here. Bam, bam. So now we have our zeros. So we're going to list our zeros on a number line. Like this number line. Oh, I don't like that. I like this. Boom. What were my zeros?
-1,
So, a different color here. Minus 1. Minus the square root of 10. Is that bigger than or smaller than? Minus 1. Minus the square root of 10 is smaller. So that's minus root 10. And then over here, that's root 10. This may or may not be to scale, because what am I looking for? Right now, I am at this step where I am testing the intervals. That's when I place my zeros on the number line, like we've done here. What am I testing them against? I'm testing them against my factored polynomial, which was dirty. Okay, we'll use that one. X to the third plus 1 times x squared minus 10. x to the third plus 1 times x squared minus 10. Now I'm looking at this guy. Boom. And I want to test these intervals. So, I need to test to the left of this. I need to test in this interval. I need to test in that interval. And I need to test in that interval over there to see where my polynomial's at. I got to see the whole thing coming. Apparently it was a hot one. Because she was all an attack. What's to the left of minus root 10? Let's do that. Let's do minus a million. Yeah? Yeah, minus a million. So we're going to go and we're going to throw those over here. Minus a million cubed. Big numbers. That's the stuff they don't like. But we're just looking at the sign. Yeah? Yeah. So we're looking for the signage in there. Minus a million to the third is going to be what? Minus something really huge. Plus 1. Is it going to be plus or negative? It's going to be negative. Now minus a million, now I'm putting it in here. Minus a million squared. Big. Positive number. It's a big positive number. Minus 10. Is it positive or negative? It's positive. Now we got to get real arithmetic-y on it. A minus number times a positive number is what? It's negative. That means my interval is negative over here. Okay. Nextly, in between minus the square root of 10 and minus 1. What's a number in there? Let's just do minus 1.5. Because the square root of 10 is like, what, a little bigger than 3? Yeah, because the square root of 9 would be 3. So let's not use 3, let's use 2. 2? 2 work? All right, minus 2. So we're putting a minus 2 in there. We're not really worried about the actual retail value of the function. We're just looking for the sign. So we put a minus 2 in here. Minus 2 cubed is minus 8. Minus 8 plus 1. What's that get you? Minus number. All right, so it's going to be minus right there. And now we're putting minus into this one. A minus 2 squared is 4. Yeah? And then 4 minus 10 is positive or negative? It's negative. So, in that interval, it's negative. So what's a minus times minus? There you go. So it's plus there. Sweet. Next. What's in between minus 1 and positive root 10?
2.
How about 0? 0 is good, right? If you're picking teams and 0 is still available, pick him. Yeah? 0 is all along the wall, right? There's all the numbers there. If 0 is still there, pick him. Why? Because 0's sick. Seriously. Seriously. Here, let me show you why. Did we talk about 0's serious emotional issues? 0 has serious emotional issues because since the beginning of time, all the other numbers have been running around saying, you're nothing, 0, you're nothing. Yeah? So 0 is seriously affected. And here's how. 3 plus 2 and 3 times 2. Which one of those is actually physically written closer? The 3 plus 2 or the 3 times 2? Yeah, the 3 times 2. So I like to call these friends and these more than friends. I think they're going to multiply. So yeah, what happens with 0? What happens if 0 is your friend? Nothing. Nothing. He doesn't change you. He doesn't change you. You're still 3. What happens if you let 0 get too close? Yeah? What happens when you let 0 get too close? He's like, oh, who's nothing now, 3? Seriously. And that's why if 0 is available, you pick him. So we're testing our intervals. 0 cubed is 0 plus 1 is 1, positive. 0 squared, 0, minus 10, negative. A positive times a negative, is that negative or positive? It's negative right there. Okay? Okay. Now to the right of this, a million. Yeah? Yeah. Yeah. So we put a million up into our factored polynomial. A million cubed, large, positive. Plus 1, still positive. All right. A million squared, large, positive. Minus 10, still positive. A positive times a positive? Positive. Now, where were we on our game plan? We just tested the intervals. Now we need to choose the appropriate interval. You ready? We need this. Oh God, it's a mess. Oh God, oh God. What am I looking for? I'm looking for this stuff right here. I highlighted it. Can somebody write that down? Because you're going to need to read it to me in a minute. So what happened when we set it equal to 0? We were using the original polynomial. We were setting it unequal to 0 in there. So now I need to come over here. Because here's the part where I'm choosing the appropriate intervals. What was that polynomial? X to the 5 minus? Minus 10x cubed. Then? Plus x squared. Minus 10, and that was bigger than or equal to 0. Boom, 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 boom. Yeah, that's it. It's ugly now, but it is. Anyways, over. We're choosing the appropriate intervals. We want to know where this polynomial is bigger than 0. So now I have a question to ask you. Which numbers are bigger than 0? Positive numbers or negative numbers? You sure? Positive. So we want to know where this is bigger than 0. So you're like, isn't that the same as this guy when we have factored him up? Yes, it's the same as this guy when we factored him up. So we want to know where that's bigger than 0. And I ask you, which are the numbers that are bigger than 0? The positive numbers or the negative numbers? Strong response. Positive numbers are greater than 0. So I want this set, and I want that set. Okay? Okay. So now I need to know how to write those in interval notation. That's like this. Square e minus root 10 to minus 1 square e. Why am I using squares? Because of the greater than or equal to. Okay. Okay. And then we're going to onion that up with square root 10 to infinity and beyond. Oh. And then it's roundy. It's roundy on infinity because you never include it. Okay? Yeah. box and flowers.